Welcome to PV Online Physics. We're going to take a look at how to solve problems that deal with acceleration. So this is an example of a word problem that you might encounter, and as we read it, it says a racing car reaches a speed of 40 meters per second. So this is going to be something that's important to us, the 40 meters per second. And at this instant, it begins uniform negative acceleration using a parachute and a braking system and comes to rest. That is going to be one of our variables. 5 seconds later, that's going to be our variable time. It says find the acceleration. So we're looking for acceleration. So listed down here, I've got our three kinematics equations. Using those three, one of those three, we can pretty much solve any kind of acceleration problem. All right, a good thing to do would be to first, let's go ahead and list the variables that we were given. And it says here that this car reaches at 40 meters per second, and then we're going to start braking. What that means is that my initial velocity is the 40 meters per second, because we're looking at the time while you're braking. So we're already moving 40 meters per second, and then we come to rest. When you come to rest, that means you're stopping. So our final velocity is going to be 0. And 5 seconds is going to be our time. And now it asks you to find the acceleration. So the unknown, or the variable that we're looking for, is A. So I have a question mark there. Okay, so we come over and look at our equations. We've got these three equations, and you have to choose which one has the three variables that we have, plus the one unknown that we're looking at. Okay, and you'll notice that this top equation, it's got the final velocity, it's got the initial velocity, it's got time, and it's got our acceleration. I can't use 2 or 3 because they include the displacement that you're going to travel. So for part A, let's list the equation. So V final equals the initial velocity plus the acceleration times time. And for the final velocity we had, that was 0. My initial velocity was 40 plus the acceleration, and the time was 5 seconds. Okay, so what I can do is, how about if I subtract the 40 from both sides? And that's going to give me negative 40 equals 5 times the acceleration. I divide both sides by 5, and that's going to give me an acceleration of negative 8 meters per second squared. And the negative sign simply tells us that we're slowing down, and that is going to be the answer for part A. Now for part B, it says how far does the car travel after the acceleration starts? So when you're looking for how far, now we're looking at the distance traveled. So that's our unknown. Now the interesting thing here is that I could use equation 2 or equation 3, and either one of them will find the distance, and they would both give me the correct answer. But let's go ahead and just use this first one here, that the distance equals the initial velocity times time plus 1/2 the acceleration times time squared. The distance then is going to equal the initial velocity, which we said was 40. The time is 5 seconds, plus 1/2 times my negative 8 times 5, and don't forget that the time is squared. Okay, so 40 times 5 is going to be 200. Now this is going to be a negative term because of the negative sign with the acceleration. So if you take 4 times, and I'm getting 4 by taking 1/2 times 8, so 4 times 25 is 100. That's going to give me a distance then of 100 meters. There you go. So now you're going to use the same approach using one of those three equations and solving for your unknown. Good luck.